Okay, so number 2, some classes we got this far and some classes we didn't. So you can fast forward if we already did number 2 in your class. So we have 6 root 5 times root 11. There's an invisible 1 here. So we're going to multiply 6 times 1 and get 6. Root 11 times root 5, we get root 55. Then we have negative 4 times 1 root 11. We multiply the negative 4 times the 1, that gets us negative 4. And there's nothing to multiply the root 11 by, so we just keep it as root 11. Negative 3 times 6, negative 18. Now we multiply what's under the radical. Root 5 times root 5 is root 25. Some of you may actually have written that as negative 18 times 5, because you know that root 5 times root 5 is 5. That's fine. 7 times 6, 42, and root 5. Then let's see, I'm kind of going out of order here, but negative 12, negative 4 and negative 3 is positive 12, and then root 5. 7, negative 4, negative 28. Now we're not done, because just having the answer in the box is not sufficient. We need to take these terms out of the box. So what we're going to do is we're going to start with the highest irrational number, which is root 55. So we have 6 root 55 is our first one. Some people lightly cross these out when they're done. I also have negative 18 root 25. That's the next highest. I have negative 4 root 11. And I have, two different things that are root 5s. I have a 42 and a 12. So what is 42 and positive 12? That's 54. So what we're going to do is we actually add the things inside the boxes. And when you're adding radicals, you actually keep the radical the same. Very similar to if you had 42x plus 12x, we would say that that was 54x. Likewise, if you have 42 root 5 plus 12 root 5, we'll say that it's 54 root 5. Now I know that the Khan Academy video did this by factoring out the 42 and the 12. The truth is you get to the same answer if you just add the coefficients. So anyway, my next term here, as we've just discussed, is 54 root 5. And that leaves me with one last thing, which is negative 28. Now the last step in these is to see if there's anything that you can simplify or combine further. Root 55, well, the only factors of 55 are 5 and 11, so I can't simplify that square root. The factors of 25 are 5 times 5. In fact, 25 is a perfect square. So I'm going to rewrite this as 18 times 5. Negative 4 times 11, 11 is prime, so it's going to stay irrational. 5 is prime, there's no factors there that we can simplify. Negative 18 times 5 happens to be negative 90. So now I have 6 root 55 minus 90 minus 4 root 11 plus 54 root 5 minus 28. And you can see here I have two terms that are called constants. They don't have a irrational number attached or a variable. So if I add negative 90 and negative 28, I get 8, negative 11, negative 118. So my final answer, 6 root 55 minus 4 root 11 plus 54 root 5 minus 118. That is my answer. Okay, so I'm going to go on to letter E. This is numbered strangely. Letter E asks us to rewrite in combined form. So what we seem to have here for this one is just a bunch of multiplication. I have 8x times negative 3x times 4y times y. So what we do is we multiply the coefficients of like variables. So the x's, they're alike, so I can multiply their coefficients. And I'm going to get negative 24. I can also multiply like variables. X times x is the same as x to the first times x to the first. You add the exponents, so it's 24x squared. You probably remember x times x equals x squared. What about 4y times y? Well, that's just going to be a 4 times an invisible 1. And then y times y is y squared. Now what we can also do, even if the variables are different, we can multiply the coefficients. So negative 24 times 4 is, let's see, negative 96, x squared, y squared. Okay, we can do this because it's multiplication. If it were addition, we wouldn't be able to do this. This is our final answer. If you notice, all this is the final answer written in somewhat factored form, right? Okay, now let's do one that's 9 root 6 times 4 root 7. When you're multiplying irrational numbers, you can multiply the coefficients and you can multiply what's under the radical. That doesn't work for adding and subtracting, but it absolutely works for multiplying. So I'm going to multiply the coefficients, and I get 36. And then I multiply what's under the radical. I keep the radical, and I get root 42. Then I just want to check, can I factor root 42 into a perfect square and another number? And I can't. If you did a factor tree on it, you'd get 2 times 3 times 7, and that's as far as you can go. There are no pairs there to take out. So that's the answer to that one. And letter H, oh my gosh, there are 2 letter H's. The second letter H is labeled as a challenge, and it's 5 root 14 times 3 root 6. Well, 5 times 3, that's not very challenging. That's 15. 14 times 6, oh, I need to do this one. Let's see, 14 times 6 is 4, carry your 2. Oh, I knew that. 84. Root 84. Well, that's not a challenge. So you know what I'm thinking? I bet this simplifies. I bet this simplifies. And the first thing I'm wondering is 4 a factor of 84? And I think it is. I think it's 4 times 21, right? 84 divided by 4. Oops, that's a 2. 2. Well, I can just say that's 21, right? So this is cool. This is 15 times root 4 times root 21. Root 4 is the same thing as 2, so it's 15 times 2 times root 21. Not sure if you can still see that. So what I have now is 15 times 2 times root 21, which means I have 30 root 21. That's the answer. Letter I, you're just going to multiply the 6 and the 8. So you're going to get 45 root 31. I don't think I'm going to do that one for the sake of time on the video. So letter I, you get 48 root 31. And then, whoa, look at letter L. We're going to have a lot of terms to combine here. When we are adding or subtracting, we really think of the radicals like x's. We cannot, and y's. We can only combine the ones that are the same. This is the rule for adding or subtracting. So what I usually do is I underline the ones that are the same. So I have 5 root 3 and negative 15 root 3. I'm allowed to combine the coefficients. So I have negative 10 root 3. I have negative 9 root 7 and 17 root 7. 17 minus 9 is 8. It'll be positive because that 17 was positive. 8 root 7. That is my final answer. And letter M, same idea, only now we're using variables. In fact, part of the idea of this assignment is to show you that variables and irrational numbers work very similarly. So what we're going to look for is what terms can we combine. Something that you might not know is you can only combine variables that have the same variable and the same exponent. So 3x squared and 10x squared can be combined, but we cannot combine the 7x. We can only combine x squareds. So 3, we have negative 10 and a 3, so that's negative 7 times x squared. Then I have a negative 2y cubed, and I don't have any other y cubes, so I'll just keep that, minus 2y cubed. Y squared. I have 10y squared and negative y squared. Remember, that's negative 1y squared. 10y squared minus 1y squared, that's 9y squared. And the only thing I have left is 7x. Done. And I don't think I have quite enough time to go over the practice with 1/2, except for I'm going to do the number 3. So number 3 on the bottom is you have 1/2 times 4 root 8 minus 10 times 11 root 3. So here's the trick. Just pick any two to multiply and then multiply the third one. So I'm going to go ahead and multiply my 1/2 times this one. You know why? Because these are even numbers. 4 times 1/2 is 4 over 2 root 8, so I'm distributing. 1/2 times negative 10, you might already know that that's negative 5, but I'll just go ahead and do that. Oops, I'll just go ahead and do that for you. 10 over 2. And then I still have my 11 root 3. So the next thing to do is simplify. I'm going to come over here to make sure I have room. So you have 2 root 8, because 4 divided by 2 is 2, minus 5, times 11 root 3. 2 root 8 times 11 root 3. 2 times 11, 22. Root 8 times root 3, 24. Negative 5 times, then we have to do the second term. Negative 5 times 11, negative 55, root 3. I can simplify the 24. 24 is root 4 times root 6. Root 4 is the same as 2. 22 times 2 times root 6 minus 55 root 3. 22 times 2, 44, root 6 minus 55 root 3. That is my answer. I hope that helped. If I went too fast, by all means go back and look at one again, or try to do one over all by yourself and see if you get the same answer. Good luck.